are on a kinematics question. So we've got an expression for velocity in terms of t, and we're trying to find, first of all, where the particle at rest. So we know it's at rest, then the velocity is equal to 0. In other words, we're finding this place here. Easiest thing to do, seeing as the graphing paper, is to graph it. So, where's the function gone? So, 0.3 t plus 0.1 power t minus 4. Obviously we don't have a t, so we're using x as our variable. Yeah, let's graph that. Try to make sure your window looks right if you can't see your graph for whatever reason. So we're trying to find this point here. So second calc 0. So enter. Enter. Oops, what happened? Okay, so we've got that value of 4.2763, 4.2763, so to three figures, it's 4.28. Okay, right, next one, find the value when the acceleration of the particle is 0. Well, we know acceleration is given by v dash t. When that's 0, we know that the derivative is equal to 0 because, so the acceleration of the particle is given by this, and when that's 0, we've got v dash t equals 0. Well, we know that this situation indicates that that's when minimum and maximum values occur. So we can see here we've got a minimum value around this point here. So again, we can just use our calculator to find the minimum value. So second calc, trying to find the minimum. So left bound. That's probably about there. Right bound. And there we go, 1.1927 to something or other. So our minimum value is going to be 1.19 seconds. Okay, number 7. Let ln x squared show that f dash. So we're differentiating. So if it was just ln x, let's remind ourselves. The derivatives here. So when it's ln x, it would be 1 over x. So we would have 1 over x squared, but we have to multiply by the derivative of what's different. So we're multiplying by 2x. That's just 2x over x squared. One of the x's cancelled, so it's just 2 over x. The tangent of the graph at the point blah blah passes through another point blah blah, find d. Oh gosh, this is very nice. How much time have I used? Okay. Okay, so when we're trying to find gradients, well, equations of tangents, we would generally be looking for finding the gradient of the line, and finding a point on it, and then substituting that in to find the missing value of c. Now, we've got lots of unknown things here. So we know that P is DFD. So this point D, this is our x coordinate. So our FD is actually going to be ln d squared. Hopefully you're all happy with that. So all I've done is put the value d in here. So that's told me what this y coordinate is. We know that the derivative tells us the gradient of the graph. So at this point P, our x value is d, so the gradient is going to be 2 over d. So what we would say is that we know that our equation is y equals 2 over dx plus c. Now at this point we now put in coordinates that we know for x and y. So we've got -3 equals 2 over d times, was it 1? Plus c. So we've got c equals -3 minus 2 over d, which isn't very nice. But, so we're going to go back up to here, and we've got y equals 2 over dx minus 3 plus 2 over d. Okay, so are you happy with that? That's -3 plus 2 over d. Okay. Now, in order to solve this, we need an equation with just x and y, just one letter. So I'm going to replace my x and my y with our values. So this is ln d squared equals 2 over d times d minus 3 plus 2 over d. Okay, so we need to solve this. So we would put it in the calculator. So I'm going to pause it because we're running out of time. Okay, so I've plotted them in the calculator. Obviously, I could have actually simplified all of this stuff, but I haven't. I've typed it in as it is. So I'll put the ln x squared on one side in one equation, and this other stuff on the other as another equation. Make sure that your screen, you can see that they meet each other. So I had to change my view window so I could see where they met. So they meet in the negatives area. So I'm trying to find this point here. So second calc, we're looking for where they intersect. So we're trying to find this point here. So the first curve. So just make sure it's close to where the intersection happens. And it tells us it's at -1.305.